Next, we'll be learning about trigonometric ratios of some specific angles, where we'll be learning the values of some of the standard angles, which will be 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So we'll be talking about first trigonometric ratios of 45 degree angle, and let's see how we can find out the value of it. So in order to find the value of 45 degree for any trigonometric ratio, what we'll do is we'll take a right angle isosceles triangle. So here these two sides are equal. Name it as ABC, where angle B is 90 degree. Now if I use Pythagoras theorem here, so what we can say that AC square will be equals to AB square plus BC square. For convenience, let's take BC as A. So AB will also become A, and when you find the value of AC, it will be equals to root 2A square, which will be root 2 times A. Now we'll find the value of the trigonometric ratio. So if I want to find sine of angle A or angle C, in this case, remember by angle sum property, angle A and angle C both will be equals to 45. As it is given that two sides are equal, so two opposite angles will be equal, and angle B is already 90, so angle A and C both will be 45 degree here. So if I'll find sine 45 degree, which is opposite upon hypotenuse, here since both the acute angles are 45, it is meaningless that which angle we take, we are going to end up with the same value. So sine 45, if we'll take, we'll get as A upon root 2A, which will be 1 upon root 2. Cos 45 degree will be equals to also A upon root 2A, which will be 1 upon root 2. Tan 45 degree will be opposite upon adjacent, which is A upon A, that is 1. Cot 45 degree will be equals to adjacent upon opposite, as both are equal, it will be 1. Then sec of 45 degree, which will be hypotenuse upon adjacent, and the value of it will be root 2. And cosec of 45 degree will also be root 2A upon A, that is root 2. And we got the value for all trigonometric ratio when the angle is 45 degree. Next, when we talk about the trigonometric ratios of 30 degree and 60 degree angles, in that case we'll be taking an equilateral triangle, and we know in equilateral triangle all the angles are equal, and we'll draw perpendicular from A to the opposite side BC. Now we know in equilateral triangle, when you draw perpendicular, it will bisect the opposite side also, as well as it will bisect angle A here. So this angle will be 30 degree, angle 30, this will be angle 60 degree, and angle C will also be 60 degree. Now if you'll take, let AB equals to BC equals to AC equals to, generally you can take A, but I'm going to take here 2A, as we are free to choose whatever side we want to take. This way you can avoid writing the fractional value. So we'll take AB equals to BC equals to AC equal to 2A. That means we'll get the value of BD equals to DC, that will be equals to A. Now in triangle ABD, the value of AD will be equals to square root of AB square minus BD square, which will be 2A whole square minus A square. On solving, we'll get it as root 3A square, which can be written as root 3A. And now if we try to find out the trigonometric ratio for angle 30 and 60 in triangle ABD, now we'll write sine 30. Sine 30 degree will be opposite, which is BD upon AB, which will be A upon 2A, that is 1 upon 2. Cos 30 degree, that will be adjacent, AD upon AB, which will be root 3A upon 2A, which is root 3 upon 2. Tan 30 degree, it will be equals to opposite upon adjacent, and that will be equals to A upon root 3A. That will be equals to 1 upon root 3. If you find the value of cot 30, then that will come as root 3, and sec 30, that will be equals to 2 upon root 3. Cosec 30 degree, that will be equals to 2. Similar way, if we will find for 60 degree, then we can write in triangle ABD sine 60 degree. For that, the opposite side will be AD upon hypotenuse AB, and that will be equals to root 3A upon 2A, and that is equals to root 3 upon 2. Cos of 60 degree, that will be equals to adjacent, which is BD upon hypotenuse AB, and that will be equals to A upon 2A, which is 1 by 2. Tan 60 degree, that will be equals to opposite AD upon adjacent BD, that will be equals to root 3A upon A, and that will be root 3. And the similar manner, we can find out the values of cot 60. So cot 60, on solving you'll get it as 1 upon root 3. Sec 60 degree, that will be equals to 2, and cosec 60 degree will be equals to 2 upon root 3. So this is how we are going to find out the values of 30 degree and 60 degree for the respective trigonometric ratios. Now if you talk about for trigonometric ratios of 0 degree and 90 degree, so it is mostly based on the analysis that if you see in the first case, if we will move this point, we'll reduce the length of BC, then as you can see in the diagram, there will be a time when C and B will coincide. So in that case, what will happen is the value of BC will become 0. And if the value of BC will become 0, what will get it as sine of angle A if I will take. So this will be BC upon AC, and if the angle A becomes 0, that means BC will be 0. This will be 0 upon AC, it will be equals to 0. Then cos A, for cos A it will be adjacent AB upon AC, and if angle A is 0 and B and C are coinciding, then the value of AB and AC will be approximately equal. So we can write it as AB upon AB, and that will be equals to 1. Then similar way we can find out the value of other trigonometric ratios also, and on solving we'll get tan A, that means tan 0, which will be equals to 0, that is opposite upon adjacent. Cot A will become adjacent upon opposite, so 0 will be then the denominator, it will be not defined. Then when we talk about sec A, that will be the reciprocal of cos A, which will be 1, and the reciprocal of sin A is cosec A, whose value also will be not defined. Now in the second diagram, if we'll check, like if suppose we want to find out the value for 90-degree angle, then in that case, if suppose we are taking A to a point B, because if angle A has to be 90, the point A and B has to be coinciding. So in that case, what we'll observe is that AC will be equals to BC. And so in this case, if I'll try to find out sine A, which will be, which one? Which will be opposite BC upon hypotenuse, that will be also A equals to BC, and that will be equals to 1. Then if you'll take cosec A, which is the reciprocal of sine A, so its value will be 1. Cos A, that is adjacent upon hypotenuse, that means AB upon AC, and as AB will be 0, the value of cos A will become 0, that means cos of 90-degree angle will be 0. In this case, remember here that angle A equals to 90 degree, and in the previous case, angle A equals to 0 degree. Then when we talk about CK, that will be not defined. And then tan A, which will be opposite upon adjacent, that will be BC upon adjacent AB, so that will also be not defined. And cot of angle A, which will be AB upon BC, that will be 0. So this is how we'll be finding out the values of these trigonometric ratios for angles 0, 30, 45, 60 and 90 degree. So based on the values what we have got, we'll summarize it in a table. So sine of 0 degree will be 0, sine 30 is half, sine 45 is 1 upon root 2, sine 60 is root 3 upon 2, sine 90 is 1. Then cos of 0 degree is 1, cos 30 is root 3 upon 2, cos 45 will be 1 upon root 2, cos 60 is half, and cos 90 is 0. Now further moving on, where the tan, cot and sec, cosec will get the values as tan A, it will be equals to 0. This will be 1 upon root 3, 1, root 3, not defined. Cot A, it will be not defined, root 3, 1, 1 upon root 3, 0. Ck, which is the reciprocal of cos, it will be 1, 2 upon root 3, root 2, 2 and not defined. The value of cosec A, which is the reciprocal of sine, it will be not defined, 2, root 2, 2 upon root 3 and 1. Now one thing we'll observe here, that when you talk about the trigonometric ratios of sine, then as the angle increases, the value will also be increasing from 0 to 90. If you talk about cos, then as the angle increases, the value of cos will decrease. Again for tan, the value will increase from 0 to 90. For cot, it will decrease. For sec, the value will be from 1 to not defined, so it is again increasing. And for cosec, it will be decreasing. Now there is a shortcut way to remember this in case if we forget it. So how we remember it as that once we have drawn the table and written those angles, so we will write it as 0, 1, 2, 3, 4. Following which We'll divide each of the number by 4. And then we'll take the square root of it. Now on solving it, whatever value we'll get, that will be the value of sine of 0, 30, 45, 60 and 90 respectively. And that's how we can remember it for the long term. Now let's see some question based on it. So here the question is, evaluate the value of sine 60 degree into cos 30 degree plus sine 30 degree into cos 60 degree. So here if I write sine 60 degree into cos 30 degree plus sine 30 degree into cos 60 degree, we'll get it as sine 60 is root 3 by 2 into cos 30 is also root 3 by 2 plus sine 30 is 1 by 2 into cos 60 is 1 by 2. This will be 3 upon 4 plus 1 by 4, which will be 4 upon 4, and the value will be 1. Next question is that evaluate the value of 2 tan square 45 degree plus cos square 30 degree minus sine square 60 degree. So this is 2 tan square 45 degree plus cos square 30 degree minus sine square 60 degree. It will be 2 tan square 45 degree. We know tan 45 is 1, so this will be 1 square plus cos square 30 degree. So we know cos 30 is root 3 by 2, so this will be root 3 by 2 whole square minus sine 60 is also root 3 by 2, so this will be root 3 by 2 whole square. In this case, this will be 2 plus this will be 3 upon 4 minus 3 upon 4. We can cancel 3 upon 4 and 3 upon 4. We will get the value of it as 2. The next question is evaluate 5 cos square 60 degree plus 4 sec square 30 degree minus tan square 45 degree upon cos square 30 degree plus sine square 30 degree. So substitute the values of it. What we'll get it as? It will be 5 into cos 60 is 1 by 2. So this will be 1 by 2 whole square plus 4 into sec 30, which is the reciprocal of cos. So we'll get it as 2 upon root 3 whole square minus tan 45 is 1. So it is 1 square. Now that will be divided by cos square 30, which will be root 3 by 2 whole square plus sine 30, which is 1 by 2 whole square. So the numerator will become 5 upon 4, as 1 by 2 whole square is 1 by 4, plus it will be 4 into 2 by root 3 whole square, that will be 4 by 3, it will become 16 upon 3 minus 1 upon, we will get 3 upon 4 plus 1 by 4. Now on solving the numerator part, if you will take LCM for it, we will get 12, this will be 4 3s are 12, this is 15 plus 3 4 times 12, so this will be 64 minus 12 divided by 4 upon 4, and which can be written as 64 plus 15, it will be 79 minus 12 divided by 12, and 4 upon 4, that will cancel. So we'll get the value as 67 upon 12, and that will be the answer of it. Next question is that if tan a plus b is root 3 and tan a minus b is 1 upon root 3, where a plus b lies between 0 to 90 degree and angle A is greater than angle B, we have to find the value of A and B. Now here what we'll do is we'll use the concept where we have discussed that as long as the angle remains same, the value of trigonometric ratio does not change. So as we know that tan a plus b is root 3, which can be written as tan a plus b equals to, we know the root 3 value is for tan of 60 degree, and as the two trigonometric ratio tan a plus b and tan 60 degree are equal, then that implies that a plus b and 60 will also be equal. That is the first equation. Similarly, when we take tan of angle A minus B, which is 1 upon root 3, we can write it as tan of A minus B equals to tan of 30 degree, which will be A minus B equals to 30 degree. Now this is equation 2. Now we are having here two equations with two unknown, and we know how to solve these equations. So when we add 1 and 2, we'll get 2A equals to 90 degree, and that means A equals to 45 degree. So that is angle A. Now from first, the value of angle B will become 60 degree minus angle A, which will be 60 degree minus 45 degree, and we'll get the value of B as 15 degree. So therefore, angle A is 45 degree and angle B is 15 degree. And this is one of the important questions